Hey folks, let me just start off by apologizing about my voice. But the doctor told me this afternoon that I am not allowed to come back to school tomorrow or the next day. So I don't want to get behind in our class. So I'm going to go through a video with you as quickly as I can. This video is going to be longer than most, but basically it's going to be a whole entire lesson so that we don't get behind. Alright, so let's look at section 9.6 first. And in section 9.6, you've already had to graph the parents. Now the nice thing is this whole table of values, you only have to do that in the parents. You'll never have to do that for any of the other graphs that we do from this point on. Things that I'm going to refer back to frequently is this equation here that's highlighted in blue. I'm also going to be referring to the two-parent graphs. There's a sine parent, there's a cosine parent. We talk about the beginning, the middle, the end, and the two quarters. So you'll notice that for the sine parent, the beginning and the middle and the end, all three of those are x-intercepts, and the two quarters are maxes and mins. So that's what I mean by those words. All right, so the first thing that we're going to look at is the amplitude. You learned in the other video that amplitude is just simply how high and how low. All right, so refer back to that standard equation that was highlighted in blue, and the amplitude here is going to be 3. So you notice on my graph I've already marked how high and how low that my 3 is going to go. Just pick any spot and call it 3. All right, so go all the way to the end. You'll notice that there's 4 tick marks that I've marked on your graph. Go all the way to the end, and you ask yourself, how far out did the parent go? Well, the parent went out to 2 pi, so that's going to be my ending value. And I'm going to use the following phrase over and over and over again. And it's going to be take half, and count. So if you take the number 2 pi and you take half, you're going to get 1 pi. That's going to be your midway point. If you take half again, you're going to get pi over 2. And now all I have to do is count. You've got 1 pi over 2, 2 pi over 2. The next thing should be 3 pi over 2. And then if you keep on counting, this should be 4 pi over 2. And that works out. All right, so this is a sine graph. The sine parent begins at the origin. So you see I already have that marked. Not only do I have that marked, I also have the middle and the ending marked as my x-intercepts. We've got here the high point, the maximum, comes first. My minimum is already marked. And then I can just connect the dots. These are not straight lines. They are curved. I should easily be able to see pieces that are concave up or pieces that are concave down. Okay, moving on to the next example. Here, my amplitude is going to be positive 3/4. We'll go back to the formula for amplitude if that confuses you a little bit. But remember back in Math 110 what a negative out front did. It always reflected my graph over the x-axis. So that's what's going to happen here. So you see I've already marked my 3/4 on the graph. Let's go all the way to the end. And at the end you have 2 pi. Take half, that's pi. Take half again, it's pi over 2. And then count 1/2, 2/2, 3/2, and 4/2. Cosine graph normally begins at the maximum. Notice this one is going to be reflected over the x-axis, so I'm going to start at the minimum. The quarter points for my cosine parent are my x-intercepts. The middle point is my maximum. So we can go ahead there. I've got it all filled out, and you can fill in your curves. Okay, then we talk about period. So notice the equation there, the formula, 2 pi over b. So we're looking at example 3. And my amplitude is going to be 3. My period will be 2 pi over b, which is going to be 2 pi over 2. If you don't know where I got that b from, then go back to the standard equation that was highlighted in blue, and you'll see where the b is. Reduce that, and you're going to get pi. Now, the period is where my ending is. So in the last two, we ended where the parent does, which was at 2 pi. But this one has a different period. So now we are ending at pi. So our final value is pi. But you're going to do that same process. Take half, and count. So if you take pi and you take half, that's going to be pi over 2. Take half again, that will be pi over 4. And then you want to count 1/4, 2/4, 3/4, 4/4. This is my sine graph. The sine graph begins at the origin. Notice I've already marked the beginning, the middle, and the ending on the x-axis. And my maxes and my mins are at the quarters. Oops. So go ahead and fill in your curves. By the way, notice that those two pieces that I just drew, those are both concave down. This next piece is a concave up piece. And the final piece is also a concave up piece. I should be able to see that on your hand-drawn graph. All right, for the phase shift, formula here is just D. Again, go back to that standard equation if you forget what D is. The amplitude on this example is 3. The period is going to be 2 pi over b, which is just 2 pi over 1, which is 2 pi. And the phase shift, think back with me to something that you did in Math 110. Remember in Math 110, you had something like y is equal to a times the quantity x minus h squared plus k. Do you remember that this piece told you to move right and left, but it was always backwards from what you expected? So if it had said x minus 3 quantity squared, we would have moved to the right 3. Well, that's exactly how this is going to work for trig. And so what we have here is that we're going to move to the right 3 pi over 2, my d value. You must show me the direction, not a pos neg. You must show me the direction as well as how far you're going. Now to graph this, what you want to do is pay attention only to the pre-shift stuff. So don't pay attention to the phase shift right now. Only pay attention to amplitude and period. So we'll go ahead and we'll put 3 on our graph. My period's 2 pi, so go all the way to the end. Now before I do this, can you think ahead a little bit? Do you see how if I, don't write this down, if you see how if I put 2 pi here, but then I have to shift my graph to the right, I'm going to run out of paper. So what I need to do in this one, I need to plan this a little bit better. And so instead of putting 2 pi here all the way at the end, I'm going to make a new ending, and that's going to be this one right here. Take half of that, that'll be pi. Take half again, that'll be pi over 2, so you have to make a new tick mark for that. And then you'll count. So 1/2, 2 halves, 3 halves, make a new tick mark, 4 halves. So you're just squeezing the x-axis in so that you have room to shift to the right. Now, remember you're ignoring the shift right now. You're only paying attention to amplitude and period. This is a sine graph. So let's go ahead. I'm going to just put some x's. Don't draw the sine graph. Just put some x's to show where the original 5 magic values are. So start at the origin. Go to the max. Back to the x-axis. Down to the min. Back to the x-axis. So I have 5 magic values that I've marked. Now all 5 of those values need to be shifted to the right a distance of 3 pi over 2. Look at my graph. How many blocks is 3 pi over 2 worth? It's worth 6 blocks. So you want to take all 5 of your magics and shift them to the right 6 blocks. So I'm going to do this one by one. So let's start at the beginning. Let's start at the origin. Take the origin and shift it to the right 6 blocks. So 2, 4, That's going to land on 3 pi over 2. And I'm actually going to put a point there, not an x. Go to your maximum next. Let's take it and shift it 6 blocks to the right. Put a point. Then go to your next x-intercept, the middle. Take it to the right 6 blocks. Then to your minimum. Take it to the right 6 blocks. And lastly, your x-intercept, the ending value, take it to the right 6 blocks. Now connect your coordinates with your curves. And you've got your sine graph. But there is one thing that's missing. You still need those magic values. So the nice thing about this one, if we just simply take the values that we had to begin with and just keep on counting, then we'll be able to get our last 3 values. So we had 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. The next one will be 5 pi over 2. The next one would be 6 pi over 2, but I'm going to write 3 pi because that's reduced. And after 6 pi over 2, you have 7 pi over 2. So that now all 5 of my magic values are named. Okay, let's go to the next one. Now the problem with this one is that it does not match my standard form. So go back and look at that blue highlighted standard form. Do you see how the x is not standing alone? So we need the x to be standing alone, which means that we have to factor a 3 out of both of these pieces here. So remember, factoring is just done by division. So I'm going to factor a 3 out. That leaves me with an x plus, over here on Scrapwork, if you need to see the math, if you take 3 pi over 5 and divide by 3 over 1, all you have to do is invert and multiply. Your 3's will cancel, leaving you with just a pi over 5. An easy way to check your work on that is to redistribute and see if you get the same thing that you started with when you redistribute. Okay, so now my amplitude is 1. My period is 2 pi over 3. My phase shift, remember you got to give me both the direction and the distance. So this is going to be to the left, pi over 5. All right, so remember when you're drawing, ignore the shifts so far. And only pay attention to the amplitude and the period. Now in this one, if I'm thinking ahead, since I have to shift to the left, I won't be running out of paper, so I can use up the whole x-axis that I have. So we have 2 pi over 3 for the ending. Okay, so now all of a sudden this is going to be a little different. So take half of that. Now, the mental math that I'm thinking is 1/2 of 2 pi over 3. The 2's cancel, leaving you with pi over 3. So when you want to take half of something and you don't know exactly what that is, just multiply by 1/2. Alright, so half of 2 pi over 3 is 1 pi over 3. Half of 1 pi over 3 is pi over 6. Again, do that math. You'll see that I'm right on that. And now I can count. So I have 1/6, 2/6. The next one is 3/6, but I'll write pi over 2, reducing my fractions. After 3/6 is 4/6, and that does match up with that. This is a cosine graph, so I need to start at my maximum. So my amplitude is 1. And since I'm going to be shifting to the left, let's go ahead and extend the x-axis to the left. So we start, I'm just going to leave some x's here because this is not my graph. This is pre-shift. So start at the max, go to the x-axis, min, x-axis, max. Now I need to take my 5 values and I need to shift them to the left pi over 5. And you say, I don't know where pi over 5 is. You're right, you don't. But wouldn't you guess that the distance of pi over 5 is somewhere between pi over 6 and pi over 3? Because 5 is between 6 and 3? And not only that, wouldn't it be closer to the pi over 6 than it would the pi over 3? So what we're going to do, we might not be exactly spot on accurate, but what we're going to do is we're just going to give a good guesstimation of pi over 6. I'm sorry, pi over 5. Now, how many blocks is that? Well, if you count my blocks, that's going to be 1, 2, 3, 4, 5 blocks. So my magics need to all be shifted to the left 5 blocks. Okay? All right, so my maximum up here, to the left 5 blocks, 2, 4, 5. My x-intercept, to the left 5 blocks. That's going to land me right before the y-axis. My minimum, to the left 5 blocks. There's 2, 4, here's 5 blocks. My x-axis, this one right here, to the left 5 blocks. So 2, 4, 5. And then my last maximum there, to the left 5 blocks. Now I have enough to graph my curve. But here's the tricky part about this one. I don't have any of my 5 magics, and I can't just count to get there. Now the first one's going to be pretty easy because I was at the x value of 0, and I just went backwards or to the left pi over 5. So my first one is going to be negative pi over 5. No big deal on that one. Negative pi over 5. So what do you do when you don't know what your magic values are? So I've set up a table down here. This table will always work. It's tedious, but it will always work. Get out your calculator. I want you to try this. Now what I've done is I've made a list of my original 5 values before I shifted. So that was the 0, the pi over 6, pi over 3, pi over 2, 2 pi over 3. Those are my original 5 magic x values. And then what I'm going to do is I'm going to use my calculator to subtract pi over 5 from each of those. Now, 0 minus pi over 5, that's the one that I said was so easy. You do not need a calculator for that one. Pi over 6 minus pi over 5, what you want to type into your calculator is 1/6. Don't type in the pi. 1/6 minus 1/5. And then what you'll want to do is turn that back into a fraction. And you should get there negative 1/30. Well, don't forget you had a pi in there. Okay, so that's going to be negative pi over 30. So that's going to be my second value, negative pi over 30. And then for the pi over 3 spot, do 1/3 minus 1/5. That'll give you 2 pi over 15. For the pi over 2 spot, subtract pi over 5. Again, 1/2 minus 1/5. And then for the last one, 2/3 minus 1/5. So this will give you your 5 values, and all I have to do is go in and fill them in on the chart. So that third one then is going to be, that third one will be 2 pi over 15. The fourth one will be 3 pi over 10. And the last one will be 7 pi over 15. And that will give you your 5 magic values for your final landing place for that graph. This is just a couple of things that I wanted to mention about my lab. In my lab, I don't love the way that my lab does the homework. And so what you need to understand is that, yes, you still have to do the homework in my lab, but you have additional homework on paper. Have additional homework on paper. In a minute, I will make a second video that shows you the where to find that homework. Okay, so but I'll talk about that here in just a minute. But here's why I don't like this. I am not giving you multiple choice graphs. You have to know how to graph these on paper from scratch. So this is the major issue that I had with my lab. All right, let's head into number 6. So now we're doing vertical translations. These are the ups and the downs. And so the first thing is that for number 6, notice that 4 is out in the front. If I'm given the opportunity, a lot of times I'm actually going to move that 4 to the back so that it's not confusing. And then I can easily see that my amplitude is 3. My period is 2 pi over b, which is going to be 2 pi over 1. My phase shift will be to the right pi. My vertical shift will be up 4. And then notice there's one more thing that I need to pay attention to, and that's that negative out front. And that negative tells me I need to reflect over the x-axis. Now, once again, I really only want to pay attention to everything except for the shifts. I don't want to pay attention to that first. I want to pay attention to the other 3 things. If I'm going to pay attention to the other 3 things, let's think ahead. Notice that my ending value is going to be 2 pi, but then I need to move to the right. And you see on my graph, I didn't give you enough space to move to the right. So let's do another one of those where I squish it in. So my ending value then is 2 pi. Take half, it's pi. Half again, give yourself a tick mark. Pi over 2. Count 1 half, 2 halves, 3 halves, 4 halves. My amplitude is 3. Don't forget that I'm reflecting over the x-axis, and this is a cosine graph. So since this is cosine, normally I would start at the maximum. I'm going to start at the minimum. Go to the x-axis, the maximum, x-axis, back to the minimum. Now, this time around, I need to do 2 different shifts. First, I need to shift to the right pi. Well, on my graph, a distance of pi is 4 blocks. So I want to go 4 blocks to the right. All of my magics are going to go 4 blocks to the right. But not only that, I also want to go up 4. So not only will my magics go 4 to the right, they're also going to go 4 up. I can do both of those at the same time. All right, so let's start at the minimum, the very first coordinate. Go to the right 4, go up 4, and make yourself a coordinate. Then let's go to the first x-intercept. Go to the right 4, go up 4, make a coordinate. Then to your maximum, go to the right 4, go up 4, that'll land you in the sticky note. And back to your x-axis, go to the right 4 and up 4. And lastly, back to your minimum. Go to the right 4 and up 4. Don't draw a mountain. Make sure I can see your concavity. This first piece is concave up. The next piece is concave down. The third piece is concave down. The last piece is concave up. Now, on this one, to get my other magic values, notice they just land every 2 blocks. So I can just go back and count like I did earlier. So you've got 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. The next one will be 5 pi over 2. And then 6 pi over 2, which will be 3 pi. Right, the last one I'm going to leave for you. Try that on your own and see if you can get it. If you want to text it to me, a screenshot, ask me if it's right, I would be happy to do that. Thanks, guys, for putting up with this very poor sounding video, and I'll get you another one to show you where to go to get your homework that you'll be doing on paper. Thanks.